So just first, some main things, just gentle reminder. The test will be held in the Friday of the last week, which is 3rd of December at night, 7:30 to 9, so 1.5 hours. So if you, as said in the announcement in the blackboard, if you are unable to attend due to some valid reason, you contact TA, then we will arrange a makeup. Okay, so but you must have to let the TA know in advance. Okay, and you have to have legitimate reason for your absence. The thing will be we will finish the random variable slides today. So we will be releasing homework 3. I think again we give you 2 weeks to do it, so maybe 2 weeks afterward. And goal today, as I said, is a random variable, and then we're in the lab because we want to talk a little bit more about the Excel and the R. Okay. Is there any question before I start? If no, then let's since I guess it's been quite a while since our last meeting, let me very briefly to talk about the idea of everything first. Yes, the question? So the question is being asked is, will the what will the text format looks like? Is it similar to your homework? The answer is should be. I mean, that it should be some somewhat similar to yeah, in the test, or you look at the my lecture notes that has an exercise at the end, so you will be similar to that style. Okay. Because it's a math statistics class, so you don't expect somewhat different from what you have been seeing. Maybe more difficult or mix and match, but it will be similar to that style. Okay. Since it's I mean, you shouldn't expect my class will be very different from other sections as well, right? Maybe because I cover R or Excel more than other sections, so you may expect I have more of those, but other than that, you should expect the main content was similar. Okay. Any question? If no, then let's very briefly review that our lectures, and then we'll go to the Excel and R. Okay. So for Excel and R, because there's so many functions, I will be very brief. I will talk about the main thing, but you will be working on your homework, then you know more. Okay. So, but just a gentle reminder what we are doing here so far. Okay. In the first topic, we talk about data, right? Talk about summary statistics, mean variance, those kind of stuff. And then the second part, we talk about topic 2, talk probability, which is trying to study uncertainty, and then we know how to define probability in classical way is a frequency, right? And then there are many things being calculated. And this chapter is about random variable. The reason why we talk about random variable is because of the outcome of sample space can be very complicated. And now we use a number to represent the outcome in sample space. So then we can combine what we learned probability, okay, with what we learned in the first class is summary statistics, right? We could talk about mean, variance, kurtosis, covariance, those kind of thing, right? And the data and the probability is related by the idea of long-run frequency, right? If you imagine that if you repeat the random experiment many times, right, the ratio will be probability, right? And those kind of thing, and the value of the random variable, how many, or average, how many times they appear will be the mean, right? So that would be the same idea. So just to recall, we have discrete and continuous, just to remind you that they are differentiated by themselves is because of the fact that the math tools you're using, okay? For the discrete random variable, you can use addition, subtraction, that kind of ordinary method, because you know there's a bar chart thing, right? Because the idea of P of X, right, is exactly the bar chart you learn in the high school, okay? And this Fx is combined bar chart, right? And then we learn the mean and variance, then you calculate all the mean and variance, and there's a several different distribution, right? You learn uniform, binomial, Poisson, hypergeometric. That different uses. Just to remind you that Poisson is very useful when you talk about count data. You're counting 0, 1, 2, 3, 4, 5, 6, okay, to many, right? That's a Poisson, okay? The counting will be very useful. And uniform will be useful when you don't know, okay? You know what are the number possible, but you know which one they are, and this is the first thing you want to do, okay? And then the next one is binomial, right? Binomial is you consider there's n independent trial, and each trial has success or failure, repeating the same thing, right? And there are a lot of cases repeating the same thing, okay? Or you assume they're independent, so that's why that's fine. But if you don't like the independent assumption, then you may want to look at hypergeometric. Okay, so this is something that you will be doing. Just remember the application. Okay, and as I said, these are all basic distribution. You can have more complicated one when you go to apply in your practice. Okay, just to remind you that how you actually are doing in practice, right? But we don't go into detail here. Say the Poisson, right? You're trying to model the number of arrival, say, customer for a coffee shop, say, right? How you actually work on this is look at data, right? You know the average arrival number, right? Rate would be that number, and that would mean, right? Because that is how you estimate the Poisson, right? I mean, that's how you have a data, you figure out the lambda, right? That's how you collect from data, okay, into fitting this kind of modeling, okay? So the data tells you what's lambda, and given the lambda, you can do the probability estimate, okay? But for the estimate, you can do business decision, right? Just to remember, then we can remind you that how much you should charge, right, based on the probability, right? Depend on the risk preference and depends on, then make your business decision, right? You can decide, depend on how many customers arriving, you decide how many cakes you should make, right? How many coffee you should do, or how many staff you should hire, right? So that would be the idea. Okay, so I'm not going to for further detail, but just to give you the taste of what it's doing. Since we cover, so continuous random variable again will be similar to discrete, but as I said, it just because of the number you assign to outcome is not a discrete but rather continuous. Okay, and in financial application, in account application, other a number, right, a money, and very naturally money will be using you'll be using the continuous random variable, right? Another way commonly used one is time, right? Time until certain thing happen, right? That we will use a exponential. Right? Again, uniform is when you use it, you don't know which one will realize. Okay. Normal, we will do it now. It will be, actually we covered last time, but we just go over again. Normal will be the things that it is so common, right? Look at the IQ, the weight, the height, everything, almost everything. And the rest of, basically the rest of our course, starting from Wednesday. Luckily, if this is not, typhoon is not hitting us again, maybe or maybe not. If not, then we'll talk about why we have seen so much normal in our statistics, right? That's why I call normal, okay? The ordinary is called Gaussian distribution invented by Gauss, okay? But now it's so common, that's why it's normal. Normal means this. So If you have not seen a normal, it's abnormal. Okay. And indeed, we didn't explicitly prove, but normal. Okay. As we said, if you look at binomial, hypergeometric, Poisson, all those kind of things. Okay. If you have satisfied certain condition, indeed you will look like normal. Okay. The bell curve is not something. So look at the graph again, right? Look at this graph. Actually, the bell curve will be very looks like those, right? This look like bell. This look like bell. Okay. Indeed, in the old days when computer is not that good, people use bell curve to approximate this. When you calculate a lot of Poisson, those kind of binomial, actually they use they call normal approximation. But there's the trick in the old days, because now your computer is so fast. In most cases, we can just explicitly calculate those. But in old days, not long ago, like 20 to 30 years ago, computer is not that quick. So so you can imagine that at those time, you may learn this, but actually you do calculations normal. But now you have later you see when in Excel, just one click, then you're done. So it's much faster. But anyway, that explains why normal is good. So just to I forgot to preview before we go to normal, and then there will be chi-square, student T and F. Okay, these three we will talk about it for the rest of the course. Okay, but we just here we'll talk about this. I'll give you idea what are those. Okay, you may not understand. Okay, that's okay. For those, you just need to know what they are. Okay, because they're too technical to explain what they are, and they're mathematical behind why this thing would make sense. But just to let you know, in advance, chi-square is try to model. Usually normal will model the mean. Okay, chi-square is model the variance. Okay, and student T will be later you will see a standardized normal. We can just imagine that when I said normal is modeling the mean, student T also model the mean. But what the difference is, when the sample size is small, use student T. Sample size large, use normal. And F later you will see is compare variance. Okay, but let's go to the more detail now. Okay, just to remind you how we calculate this, right? The normal will be have two parameter, mu and sigma square or sigma. Okay, this is the mean. This is the variance. Just to remind you that the green and the red one have the same mean but different variance. Okay, same mu but different sigma, and the difference between the two graphs is just like if the dove is slammed on top of the bell. Okay, it just flatten out. Okay, and if you change the mu, you just look at the green and blue one. You just shift the green to the blue one. Okay, the mu just shifting back and forth. The sigma is pressing up and down. Okay, so that would be the main thing. Okay, and the next what we call this is when normal with mean 0 and sigma 1, we'll call standardized normal. Okay, so the reason why this is important is because normal by itself cannot use pencil and paper to calculate. We need to rely on calculator to do calculation. So then the normalization means that you don't need to have a table for every mu and sigma. You just need one, because everything you can convert into one. And also because this normal is a symmetric. Okay, so that's why you only need to give half of the table. Okay, because from 0 to negative infinity to 0 and 0 to positive infinity, because symmetric, you don't really need to give everything there. Okay, so just to work on it again, how you work on this, calculate this value. Okay, you would be using what we call the norm dot s dot this. Okay, so let me show it to you. So what we will be doing, we'll be showing you how to calculate that. Will be norm this, standardize this, 1.4, and then true. Okay, so this is how you get this 0.9194. Okay, I hope that's not an issue there. And next one is less than 1.6. Okay, negative 1.6 will be the same idea, will be the norm as this, negative 1.6. Okay, you need to put true because just to remind you why there's a true and false. For continuous, it's almost always true because you never use the density function. Okay, you always use the cumulative distribution function. Okay. So this is what we have here. Okay. And for the Excel, the good thing is you can input any number there. Okay. But for some table, they only give you the positive number from 0 to infinity. So that's why you have to use symmetry, right? Less than negative 1.6 is 1 minus less than positive 1.6, okay? Because there's symmetry, right? Because adding up together should be 1. Okay? Is that okay? So make sure that you know how to do this, okay? And maybe I should show you how to look at the table in case, because I think maybe we'll look at it in the. So this is the C table, right? If you look at the standard, I just look at the web, let's look at very standard thing. This one is the Z table that is on the, they give all the negative one, but they're the same thing, right? So basically the area on the left-hand side. Okay. So this is the table. I guess even this is give positive one. So either you can, maybe I give you this one or I give you this one. Okay. So you can look for it. Okay. This is this kind of table. It's just a norm S dot this. Okay. For example, give you example how we do it. This is 1.4 here, right? So we just go to here, look at where is 1.4 is here, right? The column is 0, 0. So 1.40 is 0.9192. So that is what this number is. Is there any question for this table? Because this gives you this area. This is the norm dot S dot this. Is that okay? Any question? I'm asking because you do not have access to your computer when doing the test, right? So I hope you understand what's going on. Even the open book, right? It's not going to open your iPad, right? So is that okay? Is that okay? But of course, you should be able to learn that. It's not be an issue. So that will be the calculation. If you want to calculate the middle area, right? Just to remind you what's going on here. This is the following. Right? You're asking you 1.4 and 1.6. Okay. So what you want is calculate this blue area. Okay, this is what it means. Right? This is the blue area. And what you're going to do is you calculate the red area, okay, which is this guy. Okay, see, or same thing. And then you also calculate the purple area, okay, which is this guy. Okay. And the blue area will be the purple minus red. Okay, because the table gate you see here in the Excel or table I show you, right, is all the area on the left hand side. Okay, so it's just this minus this. Okay, but of course, some of the table they give you the area on the right tail, but the same thing, right? Just your mind just swap a little bit. Is that okay? Shouldn't be an issue there, but so if you're able to look at the Z table, I mean, shouldn't be an issue, right? In the test or exam, and then you should be able to learn how to use a Z table in case I give you a Z table, okay? Because you don't have access to your computer, right? Because of you can open book, open note, but probably will not be open your computer, right? Because unless we have a pandemic, then you have to do it online, and maybe you're still able to use the computer, but now we really can't do it, okay? So if there's no question, then we continue a little bit, okay? Just this one, just a gentle reminder how this one is being done. You see I'm repeating this stuff. The reason is because you were using this for the rest of your whole course, okay? So just make sure that you would have some better idea what's going on here, okay? So especially this, you will see calculation of this is frequently used, okay? This calculation you will use a lot of time, okay? So what this question is about is just reverse, okay? The question is asking, suppose this area is 0.95, okay? What is this value Z? Okay, so just reverse, right? Before we ask the Z value, give me the P probability, the area below. Now just reverse, I give the area, what is the Z? Okay, so the answer is 1.9645, okay? And this number, you remember a lot because it appears many times, but to calculate this, we'll be using the norm dot S dot inward 0.95. Okay, this is the input we put in your Excel. Okay, so if no question, let me illustrate this in the Excel. Where is it? Oh, it's not our cells here. Okay, this norm dot S dot inward and 0.95. Okay, so it's 1.645. Okay, this number you remember a lot because this will be the thing we're doing for the rest of the semester. Okay, this number you will not you remember by heart, I think. Okay, and the other way around is asking 0.975. Okay, so just change the number to 0.975. Okay, you input there. Let's do it. 0.975. Okay, not at this, but it's inward. Okay, so it's 9.95. Okay, so these two numbers are important. Okay, but you remember, say you don't have to remember in your mind because you will do it. This question you will do enough so that you know it. Okay, now let's go to here. Okay, follow the normal distribution. Okay, so in order to calculate this, okay, there are two ways to calculate. Okay, one is to transform this, okay, into the Z. Okay, so this is the official method. Okay, how to do it is subtract both sides by 20, then divided by 4, so you get -1. So you can do this is a norm as log this -1 true, you give you this answer, right? But this for the Excel is very smart, right? You don't have to do it because Excel can do this all the calculation for you, right? So what you do, you go to norm. Okay, this you put 16 there, and then you put the mean mu 20. Okay, and this one sigma is 4, right? Because this is the square root of 16. Okay, so you put 4 there, and it's true. Okay, you do that, you give the same answer. Okay, let me show you why this is true. Okay, let's do it. Norm this 16, 24 true. Okay, then it gives what we want. Okay, it's 1.154%. Okay, this is exactly this guy. Okay, so what I want you to do, just to practice, okay, is you want to do this for me. I want you to do x greater than 24 for this one, and I want you also to do the next page one, which is let me erase it. I want you to do between 16 and 24, okay, and also x is greater than 24. Okay, so let's do it now, because I want you to know how to work it out. Open your Excel and try to do the calculation for me. Maybe you need to change to the another computer, or use your one, it's fine. But Excel is not something. Then later after the break we use out, then you can change. Or you can use your own, it's fine. I don't think you have to use the one, yeah, in the lab. So give you 2 minutes to do it, and then so you have to calculate the answer. I want to calculate the second one. The probability x is greater than 24. Given x is a normal distribution with mu 20 and sigma square is 16. Okay. So I showed you how to do the first one. I hope you can do the second one. Okay. So make yourself work it out, because I asked you to do in your homework free. Okay. You would be doing something related. Okay. You would be working out. So in case you are confused now, just ask me. So once you do the greater than 24, show me the answer, and then I want you to do the next one, right? As I said, I want you to tell me how you can do the between 6 and 24. You get the answer upon 6 826. Okay, should be able to get the answer. Okay, so we do the 2 questions. Okay. So I do the first one first, then the second one I give you some time to do it further. So this one, oh, where's my internet? Yes, good. So just to read how to do it, this is the following, all right? So the question is now the mean is 20, okay? The sigma is 4, okay? So what you want is this guy, which 24 there. The question is asking you to calculate this blue area, okay? And we know the norm, this will give you the area to the right, okay? So that means that I can calculate the area less than 24, but you know the red and the blue are add up to 1. That is a complement rule, right? The total probability of the whole thing must be 1, okay? So that means that the red one, we know the answer, right? The red one, the answer for the red one, right? If the norm, this, right, 24, and then the mean is 20, sigma is 4, and then true, okay? And then because we want the blue area, so it's just 1 minus, okay? So how we just show you how we can get it in the Excel here, okay? As we said, you just 1 minus norm, this 24, mean is 20, SD is 4, cumulative is true, okay? So, oh, sorry. Okay, this is how you get this number. Is that okay? So I hope that's okay. Okay, just go back to the slide in case. Okay, so now I want the answer between x is between 16 and 24. Okay, I'll show you the answer in 1 minute. Okay, I want the next one. Okay. Okay, just go around to check if any question. If no, I show the answer. Okay, no question. Okay, no question, then it means that everyone is doing well. So let me continue one more step how it is being done. Okay, just to plot it here. Okay, sorry, I should use another brighter color here. Let me move it a little bit up. Maybe down here. Okay, so we know x is 20 again, sigma is 4. The question being asked is 16 is here, 24 is here. You want this blue area, okay? And this blue area, you want the what we call the area, and what we know is area below 24 and below 16. The difference will be in the middle, right? So just to recap, what we're going to do is we find the red area, okay? The red area will be the norm, this 16, 24, true. Okay. And We also know the not purple, maybe green. This green area will be norm, this 24, 24 true. Okay, so let me put that in the Excel, then we know the answer. Okay, so will be the norm with the green minus the red is the blue. So the green first, norm this, okay, 24, 24 true, okay, minus norm this 16, 24 true. Okay, so that's how I get the answer of 0.68269, as you can see in the slides. Is that okay? I mean, for many of you, it is too trivial, too easy, but just make sure everyone on the same page. Okay. If you question, let me know, because you should learn how to do this, right? Because after this class, if you don't know, we're not coming back until 2 weeks later, right? I think 2 weeks after, before we have a lab session again, right? So make sure you're okay, and hopefully we don't have a typhoon this week. Otherwise, we have to figure out how to do things. But anyway, any question? If there's no question, is that okay? If no question, then let's let me finish what we have right now. The lecture notes, okay? The remaining lecture notes will not be difficult. So basically, what I'm going to do in the next 12 minutes before the break, hopefully, is statement of some facts, okay? There's nothing new to learn, but there's a lot of things to remember or digest, to know, okay? So there's a bunch of facts. So I'm not trying to prove it, but I'll tell you why they're important, okay? And that will be useful, okay? The first thing I want to tell you is the following. Suppose you have two bell curves, okay? X is a bell, Y is not a bell, okay? Because X is normal, Y is a normal, okay? One very important, interesting fact is if you add two bells, turnout is another bell, okay? So the first thing is if X and Y have mu X and mu Y, the sum is also the mu. It's nothing special because you learn it, right? It's an expectation. Expectation of the sum is sum of the expectation. You know it. Same here. Variance expectation is also expectation. But the only interesting part is adding up is still in normal. Okay? So this is not true for many things, right? If you add two uniform, it's not uniform, right? If they overlap. Okay? One simple thing you can think is you roll a die, okay? It's 1 to 6. Okay? You roll another die 1 to 6. Add up these two 1 to 6 is a uniform. Suppose the die is fair. Okay? Adding these two, okay? One number you get is 2 to 12. Right? 1 to 6, 1 to 6. Adding two numbers is either 2 to 12. Okay? Before both of them are uniform. Right? Now you have 2 to 16. Sorry, 2 to 12. It's not uniform anymore. Right? Out of 36, right? Probability of having 2 is 1 and 1 is 1 over 36. Okay? Adding two uniform is not uniform. Okay, even the simplest case you can imagine. Okay, it's pretty surprising that adding up the two normal if they're independent. Okay, this thing is interesting. Okay, when we use this, we'll use this in the next couple of classes. We'll use this idea. Okay, and here the same idea if the difference is also the same. Okay, you subtract the normal, still a normal. Okay, you may ask why we talk about this. You'll be clear for the rest of the whole course. We'll be doing this. Okay, you'll be clear why we need this, but this is an interesting fact about the bell curve. Okay, I'm not going to explain further why this is true, but this is the answer we want to know. So the next thing, again, is a fact. It's what we call the chi-square distribution. Okay. So how we read the normal? In fact, the chi is look like the x. Okay. So indeed, chi-square is supposed to be x squared, and x is a standard normal. Okay. So that is why at the first line here, if z is the normal, z square will be chi-square of degree 1, only one of the x. Okay. And what it means is the bell curve. Okay. Now you take a square. So all the negative value become positive value. Okay. So let me draw a diagram. You will see what's going on. Looks like this. It's rather trivial, but so the bell curve looks like this. This is z. Okay. And what will the chi-square looks like? Okay. This is 0 here. Okay. The 0 here. Okay. Actually, this 0 still looks like here. Okay. But all other thing, right? This guy. Okay. All this will become, you add it up, it will become here. Okay. Because the square, right? So there's much fatter tail. Okay. But because of square, which means that those who are close to 0 will be collapsed further. Okay. So that's why it look like this. Okay. So this is look like the curve look like this. That's how chi-square looks like. It's like the red one. Because it just basically, what the thing is the bell there. You just put the other side, superimpose the other side. And because that will be the absolute z, then you square it, then it will be look like that. Okay. But anyway, it's not our job to explain why it looks like this and on, but just to remind you that when you have more than one app together, okay, this 3 means 3 of the app together. Okay, there's definition here. Nothing to understand, but this is the definition. Okay, if you have n of this one, each one take a square. Okay, you become chi-square n. Okay, depending on how many you add up, there will be n. Okay, so here chi-square 3 will be 3 of the standard normal add up. Okay, and then you may ask why we care about this. As I said, this chi-square we use to model the variance. Okay, variance square. Okay, itself is normal, but this one will be we'll be clear how we use this later. Okay, but this is the idea behind. So there's nothing to understand. This is the definition. You just know chi-square is standard normal square. It's chi-square 1. Okay, and chi-square 2 will be 2 square the standard normal add together. Okay, there's nothing new, but this just, you know it, this definition. Okay, there's nothing but definition. Okay, and we know how to use them later. Okay, the application is so many, so I don't is used to do the rest of our course. Okay, and here is another definition. Okay, and as I said, why we need to do this is because when you talk about normal, it's only good to have a proxy, say IQ, all those things when the sample size is small. When big, when sample size is small, we rely on this T distribution. Okay, and this T is coming from what? Okay, we'll just define it. We don't have time to prove it, but you will be defined as standardized normal over chi-square m over m is student T. Okay, so you may ask what's this? Okay, but don't worry, look at the graph, it'll be easier. Okay, this will be exactly similar to the normal. Okay, look at the infinity one. Okay, is how many, this bottom number is how many the degree of how many standard normal add together. Okay, you have more, then you have bigger number. Okay, so the key here to look at is the golden one is the normal, exactly. When you have many altogether, it's a normal. Okay. The only difference is the T is, look at the red one, there's only one. Okay. This one is a normal. Okay, home looks like normal. Okay. You can imagine what's the difference between normal and the T is the following. Have a normal bell curve. Okay. You just smash it on the top. Okay. It becomes a little bit flatter. Okay. But that's not enough. You have to lift up a little bit to side. Okay. Make it higher. Okay. So that means that student T have a fatter tail than this one. Okay. That means the kurtosis is more than 3. Okay. Just to repeat, the idea here is still T distribution is the following: bell curve, hammer, chop. Okay. It's go down. Okay. That's not enough. Okay. You have the two sides and lift up a little bit. Okay. That is how you see the red one. Okay. And of course, if this is you have more, you increase this, how many chi-square you're doing, then you go to normal. Okay. And later you will see these are with the sample size. Okay. The more sample you have, you will get to close to normal. The less sample you have, you close to T. Actually, we'll talk about this, I think, next class or the next week. Okay. But just give you an idea what they are first. Have some idea, then we don't have surprise. So overrun, but I want to finish this one. It's very fast. Okay. You give it a break. So this one, again, is just a race of chi-square. Okay. This is chi-square M and chi-square N. M of them and N of them is divided M to N. It's called F, Mn. Okay. So you can see this Fmn will be inverse with the Fnm. Okay. You just reverse this, it will reverse. Okay. But why you ask why we care about all this? Okay. Later you will see at the end of I think middle of November, should be beginning of November, we will learn why this is important. But remember what I said, chi-square is used to model the variance. Okay. So why we need to do this is compare variance. Okay. So first thing come to your mind, why we need to compare variance is variance is what? Measure risk. One way to do it. Then you want to say compare whether the risk of one asset is actually higher than other. This is the first thing you want to look at. Second, remember, variance also measuring quality control, right? So if the product have good quality control or the machine has good accuracy, you don't have variance, right? Variance is a accuracy you're measuring, right? If the production machine is producing good, which is a no variance, then it's a very good machine, right? If otherwise you're keeping, there's some errors here and there, and you suppose you want to see whether the two machines, right, have the same stability, right, or same accuracy, then you do this, right? And in the military, right, they also want to talk about whether missile hit the target or within each area, the error, this kind of stuff, right? Whether the guy is stable. Okay. The second thing you need to why you use this F distribution is what we call we'll do it. I think second last topic called ANOVA. ANOVA, right? The second last topic is analyze of variance, right? It's based on analyzing the variance, okay? And that is rely on the F, okay? And the very last part, we talk about regression, okay? Again, we use this F test, okay? So F distribution, okay? So that means we use it for the rest of whole course, okay? Here, I just introduce it at the moment, what it is, okay? But later you will see why we talk about those later, okay? At the moment, I don't talk about application, okay? But you apply for the rest of the course, okay? So sorry for overrun, but let's a break of 10 minutes, and then we will finish we will talk about Excel and R, okay? And finish the whole notes. Have a break. I'll go around to see if any question you might have. 俾我咁樣計呢種啦。個 norm 就係 norm distance， 有啲係俾呢一種咯。呢樣佢俾負啫嘛，佢就係俾負啫。呢樣個表，呢個就係俾正數咯，由0開始咯，呢個就負開始俾。有啲佢係俾呢個，有啲佢係俾呢一隻咯。但係俾隻一樣啫，因為乜都得係咪一樣？ Hi. So let's back. Okay, some of you told me that there might be typhoon on Wednesday. So it seems like no one want to make up and no one want to take the Zoom. So I guess if in that unfortunate event, we just speed up a little bit for the lecture, but hopefully not. But if that's the case, then I cannot control. So Excel. So there are many, you see a slide, there are many pages, okay? But they're so similar. So I'm not going to go over one by one. Instead, go to one or two of them, and then you should be able to do the rest. And as I will ask you later, you see the homework 3, which will be due with 2 weeks afterward. Then you will be working on those, okay? You should be able to know it. But let me talk about this, and it actually is basically for every distribution we learn, there will be 3 functions. Right? Actually 2 in this case, right? Will be the distribution function and the inverse. Okay. Actually, we learned that in our normal, right? Normal this and normal inverse. Okay. And it is same actually for binomial. Okay. We can find the p and x and inverse. Okay. This px is nothing, right? For this case, the first one is exactly the probability, okay? So it will be this, just means 5C2.3 raised to the power 2 and 0.7 raised to the power 3, okay? Not, there's no dot there, but okay. So this is exactly what this will give you, right? Because binomial is this, right? NCX p to the power x and 1 minus p to the power n minus x, okay? So binomial, you can use this to calculate directly, okay? So let me show you, because I guess you want me to actually show this to you, okay? So what we're doing is binom this, okay? 5C2, which means that you have a 5. So you want 2, okay? You want to try, you run 5 trials, okay? Each trial have probability success of 0.3, okay? And then you asking what's probability of the 5 trial, 2 of them successful, okay? And you put true there. So you want a false there. The reason is because this is asking that probability, okay? So that's P of X. Okay, one immediate question you ask is, what happens if this is changed from false to true, okay? Okay. Remember what is this guy? Let me draw a picture, okay? So what is this guy is, right? This guy will be the following, right? You just have X, you have 0, 1, 2, 3, 4, 5, right? And then this 0.3 is looks like this bar graph. This is like this, okay? 0.3 like here, 3 is also like this, and this is lower, and this is lower, and this is much lower, and this is much lower, right? This is the P of X, okay? And what's this guy, right? This is F of X. If you still remember, what are they? But this is the P of X, okay? What is P of X? F of X here, this one is asking this area plus this area plus this area, this F of X, okay? This false is just asking the bar here. When you have true, you're asking all the bar add up together, right? And that's F, right? That is, if you look at the graph again, then we'll be giving you that, okay? So now with this, actually, I can show you how we can draw these 2 graphs, okay? Because we're in Excel, okay? We can do a plot. So let me do a plot to show you how you plot this P and X, P and F, okay? In Excel, okay? So that is the 1 of thing we're doing now. Okay, so let me do it. Oh, okay. So what we're doing is the following. So we have x, okay, we have p of x, and we have f of x. What are the x value you can get is 0, 1, 2, 3, 4, 5. Okay, so let me slow down a little bit in case you want to. Okay, so what I want is, I draw this px first. Okay, just draw the px first. P of x is probability, right? The probability is 1. Is equal to binomial dist. And before I do that, I should have a p here. Probably p is what? 0.3, right? Okay, it's 0.3. Or you want to put at the top is also fine. So just to make it look nicer. So this is the yellow area we are working on. Okay, so what we're doing is binomial dist. Okay, and number of trial is actually A15. Okay, is on the left hand side I have. Okay, you'll be different or depend on where you are in your Excel. Okay, and number of trial is 5. Okay, that's unchanged. Okay, the probability. Okay, we want it to be here, right? So we're going to copy the formula. So we can just click this guy and then plus F4, then you have double dollar sign. Okay. And then we want it to be true. Okay. That's the answer. But let me show you move here. Let me show you the formula test in case you don't. B14. Oh. So in case, okay, there's no color. Okay. So that's how we get this one. Okay. Oh, sorry, this is not true because this is P of x, so it should be false. Right, this is not F. Okay, so this is to be a P1. Okay. Okay, so look at this. Okay, so now we can plot this diagram. Okay, how do you plot it? Suppose you should know it, but just highlight this data there. Okay, and then go to insert. May want to plot our graph. Okay, and this looks exactly what we want. Okay, this is P of x. Okay, it's very nice. Then we're done. A little bit too large. This is a diagram. Let me put it here. Okay, that is how you draw the px. Okay, just go around. If you see any question, you can draw this by yourself. Okay. So you can change the color, whatever, but this is how you draw the P of x. Okay. The next thing is to draw the f of x also, right? So the f of x will be very much the same. Okay. Maybe I just change here because to make it faster. So see f here, I change false to become true. Okay. And I carry all the way downward. Okay. So exactly you have f. Okay. So you can see very quickly that I'm done. Okay. You have f or an fx. Of course, you can create another table, but I just being lazy a little bit. But you should be able. You can create another column and do the thing. But I hope you're able to draw the f and the. Okay. So in your mind, you should be able to plot these two graphs using Excel without any question. Okay, that's how I draw the curve, the graph in the handout. Okay, the slides. For every distribution, you can just draw this one. Okay, that's not a big difficulty there. Okay, you should be able to calculate all this probability. How do you draw the bar graph? How do you draw the F? It's not a big issue. Okay. So in case you want to make yourself understand, okay, let's give you a exercise. Okay, do the same for Poisson. Okay, plot the two graphs for the Poisson. Okay, I have a binomial. You're able to do it for Poisson. Okay, draw the Poisson fx and px. Okay, I give you 5 minutes and I will show you how to do it. So do the Poisson, draw two graphs, px and fx. So do note that the Poisson is accounting, so you have to be a little bit more careful in the sense that because Poisson is not limited by parameter there. So what I mean is you have a lambda there. Okay, lambda is 5 in our case, right? And then x is sort of 0, 1, 2, but 3, but we do note that it doesn't end by 0, end by 5, actually go on a lot, right? So how many go on does depend on your liking, but you need to go a little bit longer than 5, right? Because 5 is just the mean, so you need to go beyond the 5 a little bit. Okay, so you would draw a px, right, and fx, and then you want to draw a two graph there. Okay, so that is what I'm asking you to do. Okay, I hope you can easily fill in the two columns and you can plot it. So I hope you should be able to do it with the Two more minutes, I will show you the answer. So, okay, let me write down the answer for you. It will be Poisson distribution with the column you want to put in. The mean will be what we happen to be. My case is B25. Then you want to use false. Let me show you the. Okay, let me erase this. Okay, I just show you the P, then after you can do F easily. Okay, so that is okay, and then just drag. Okay, And then you see here 0.18, maybe you think is enough, then you end, but if not, then you can just go down a little bit more. In this case, maybe I just go down 2 more. Okay, maybe go to up to here, maybe that's fine, it's already too small anyway, so there will be the formula here. Okay, again, we just plot this by highlighting, insert, let the recommend chart here. Okay, this is how it looks like. Okay, so this very nicely looks like bell shape, as I said, right? But the good thing about the idea you put this lambda is 5 here because you refer to this instead of putting 5 here. The reason why this is good is you can change the number. Okay, here at 5, I can change to 4. The graph adjusts automatically, right? If I put 6, then automatically adjust. So it's very rather convenient now. Okay, so you can look at how the different lambda change different shapes. Excel can be very visualized, right? So it's rather convenient, can change it. Yeah, this is very good. You can combine it to chart. This is a very nice one. Is there any question? How you draw the P? Of course, F you can draw it by changing it from true to false. It's okay. I'm not going to show it for you, but I hope there's no problem. Is there any question? Any question? If no, I want to show you the last graph before I go to R. Is how to draw when you try to draw the, say, normal. Okay. So hypergeometric is the same. It's just A and A is the same thing we have. Okay, that's directly. Okay. So that's why the reason why I use this notation is to be consistent with the Excel. Okay. So there's nothing new here. Okay. The only thing I want to say is suppose I want to draw the bell curve. Okay. Maybe I draw the normal one. Okay. The normal one, I use the norm as this. Okay, force. Okay. So maybe I just try to draw the bell curve. Okay. And the bell curve has no parameter, right? Just that is simple, right? Z. Okay. And how you're going to draw the bell curve, right? This is F. F of Z. Okay. Then you have a lot of number. Okay, we start from -4, -3.9. Okay, and go on a long way to go until 4. Okay, it's more like how many I have. I have 81 row there. Okay, from 4. Make it bigger. Okay. Okay. Then what I'm going to do will be the norm as this guy. Okay. Do remember I want to draw the bell curve, so I use the false one. Okay, not the true one. If I have tried to do this C table, I will use the true. Okay, but I want to draw the bell curve now. Okay, that's false. Okay, look like this. Now you're done, right? Because basically this is how the whole thing is being done. Let me copy the formula test here. So it's pretty trivial, right? There's nothing new there. But what I want to show you is the how to draw this graph. Okay, so just recommend chart. Okay, you can draw this, the smooth version. So that's how the bell curve comes in. Okay, or you can draw this one, also fine. I think this one is the best. Looks like, yeah, this is the nice bell curve. Okay, this is how the bell curve is being drawn. Is that okay? I mean, just to try to show you how the graph in the whole class is being drawn in the slide. So you can do it by yourself. Okay, there's nothing special for this handout in the graph in the handout. Okay, just I want to show you that. Okay, so you should be able to do everything in the slides and everything is there. Okay, and of course, if you change this to true, dealt with the Z table. Okay, so if you change it to, let me change this to just being lazy, I change it to F. Okay, and I change it to the true. Okay, and this is the Z table, right? This is Z table. Okay, this is Z table. What it means? Oh no, it's not the Z table. This is F. The Z table, I need to use the other one. The Z table, I need to use the. I have to use the inverse. Let me create a Z table there. The Z table with the probability with alpha. No, that's fine. This is the C. This is C table. That's fine. Yeah, C table is looking at the area. Yeah, this is the C table. Yeah, that's fine. Yeah. So this is sorry. This is C table. You look at the table. It's actually this one. This is the first column of the C table. If you remember what I said, it's just this one. This is Z table here, right? This is the first column on one. Maybe I go back to the other C table, this one, right? How they create this C table. Maybe we create this C table directly, okay? So let's do what they have. Let me create another one. So this is Z, okay? What they are doing is 3.6 from negative 3.6, okay? And I think they go to 0, maybe negative 3.5. And I think go to 0 at the end. This one, okay? And this is 0.01, okay? And this is 0.002. And this is the table they create. Okay, I think up to here, that's right. 0.09 is fine. So this is the table they have. Okay, so what it's doing for this one will be just what they're considering is this number, right? Is if you remember the multiplication table, okay, this is this plus B. Okay. Oh, I think they have the 0 by 0, 0 first. Okay. So this is the table they have in their mind. Okay. And what they are doing is for each value there, you calculate the Z inverse. So what the formula is norm inverse of norm S dot inverse of this guy. Oh no, sorry. Yes. True. Yes, the area. So just like this. So this will be the formula, which is exactly the same you see here. Okay, so this is how this is being constructed. So some of you asked me how this is being constructed. This is how this C table being constructed. Okay, so just to how they do it. Okay, it's just the norm S this, and you every entry add up the row and the column, and then you just create. Is that okay? I hope you're able to create by yourself. You can pick up any Z table online, you can create it by yourself, okay? There's nothing special or nothing surprising there, okay? You may need to know how this table, because we take the text, but In the real world application, just directly use the Excel. Okay. Is that okay? Because if that's okay, then we run away from the Excel, or we'll do R if there's no further question. Is there any question? So we learn how to plot the PX and FX. We learn how to do the table, normal table. I think is good enough. Okay. Is there any question? And actually, you can later you will see we have the T table. We have the F table also can be created. Okay. So you shouldn't come with a surprise. Okay. So we have the chi-normal here, and also we can do the chi-square with degree of freedom, the DF. Now, how many of them? And later you will see this will be very useful. T also the same. You have the T, the same, the normal curve, P and F. F also the same thing. Okay, I'm not going to go one by one. This chi-square, F, and T, we will later use it. Okay, when we talk about next class or the class later. So don't worry about it. But you should know how to do the normal, exponential, how to do it, and that will simplify your calculation a lot. Okay. So before we talk about R. Okay. Any question? Okay. There you can see if you know Excel, R will be easy because it's exactly the same thing. Okay. But just a slightly different functions and slightly different way to handle things. Okay, is there any question? If no, then let me how about this? Okay, for the R, the way they do is the function is really interesting. They have the D and the P and the Q. Okay, D is the probability function. Okay, that will be very different the way we use the notation, and P will be the F. Okay, so I don't know, F is P and D is P, but I hope it's not confusing you. In Excel, this is saying this is false, this is true. Okay, but in R, they have two different functions. Okay, so no need to thought about true and false. Okay, only, so I mean, just to, some of you are confused by this one. Okay, so what this is exactly binomial this 2 and 5 and 0.3, but do you have false? Okay, and what is this guy? Will be just everything the same but true. Okay, so let me go to the R and show you all this. Okay, go to our studio again, start up here. Then what we want is to maybe we want to have a bigger font size. Now it's a little bit too small, so I just change a little bit bigger first. Apply. Then we start. Okay, we have our there. How we start? File, new file, and our script. So this open there. Okay. So let's try the simplest thing, right? The distribution binomial. We put 2 and then 5.3. Okay. So once you run it, okay, you send it there, give you the answer at the bottom. You can't see it a little bit upper. So here is the answer. And move a little bit. So this is the answer. And this is the probability. Okay. And here the good thing about the R is a vectorized program. It means that you don't have to input one number by once. You can input a bunch of numbers. Okay. What do I mean by that? Is let's do the following. X is equal to C 0, 1, 2, 3, 4, 5. Okay. Then instead of putting one number, I input X directly, okay? What we'll get is the whole list of the entry and put the result there, okay? X can be 0, 1, 2, 3, 4, 5. And then R will calculate all input, okay? Let me run it. Okay, let me run this two line. You will see X are all 6 value, and R is very interestingly, they loop over it directly. Maybe I put an enter there, if those people can't see the back. Is that clear? So basically, it's just like for each entry you put in. Okay, so that is a good thing about R, okay? So you can see when we do Excel, we have to copy and paste and do everyone, right? R is already doing it for you, okay? So by default, it's already a spreadsheet idea. Okay, so that's why R is kind of convenient when you handle a large set of data, right? Because you don't have to go all the way down. Is that okay? So, and because of this, you can create plot, right? So I'll now teach you how to do the P plot, okay? How do we plot the P? Okay, so we'll do a bar chart, okay? So how do we do it? Okay, so we call this Y, right? Because this is what the X value is, this is what the Y value is, okay? And then what we're going to do is to define data, all right? This is called data frame, okay? X equal to X and Y equal to Y. Actually, XY is fine, XY, okay? So if you do this, right, you will see the data looks like that. Okay, exactly what you expect when you see the Excel. Okay, let me go back to the code thing. You see it, right? X is this, and Y is this. This is what the data, right? And then just to remember, you use the plotting. We use the ggplot library. ggplot2 it's not been installed yet, so go back to here, go to package, install, we do ggplot2, okay, ggplot2, and install that, ggplot2, install the package. So you should see ggplot2 is here. Either click this one or type as I said, okay? Is that okay? You install that. Is there a question? But let me plot it and I go around to see if you can plot this one. So how you're going to plot it is will be ggplot, okay? And then put the data there, all right? And maybe enthusiastic, X equal to X, Y equal to Y, okay? And then what we want is to plot a genome bar, okay? And that's fine. What's wrong there? Let me check. Oh, they want to do it first. Genome column, maybe. Yes, genome column. So that's how you plot the D. Okay? You plot the P of X. Okay. So of course here you can do it a little bit more better way, right? Instead P is 0.3, you can change the P there. Okay. Then once you do it, you can see the same graph here, but 3 I can change to 0.5. Then I can just rerun the graph. Okay, so I can change the number at the beginning, and then I can do the same. Okay, So the other thing about this is more convenient in Excel is I can make also the n a parameter. Okay, how do we do that? Okay, so it will be the following. We're doing n is equal to 5. Okay, and how to make this number conditional n? Okay, there's a shortcut there. We'll be doing the following: 0, comma n. Okay, 0 colon n. Okay, 0 colon n means 0, 1, 2, 3, 4, 5 to n. Okay, so and then change the n here. Okay, so this is the most general model you can have. It's just like you plot this or like this. There's nothing changes. Very comforting, but we change to 6. You can plot again. This gives you the 6. Okay, so this is the final graph for the PDF, right? Or sorry, paragraph of the PX of the binomial. Okay, you can change it from D to P, become the FX. Okay, suppose I don't like this D. Okay, I change to P. Okay, then what I draw will be the F. Okay, but I just change here to D first. Okay. And some of you may ask, can you plot the F and the P the same graph? Okay, the answer is yes. How you do it? You can have Z, which is equal to the P. Okay, and you want X, Y, Z here. Okay, and what you're going to do is you have one column here, and you get another column. Y equal to Z. Maybe I use line because that would be a better choice. Okay, so this would be the diagram you have is I have X is the value of X, right? And the Y will be the PX, and the Z will be the F of X. So you can see a plot. F is P is here, F like this. Okay, I hope that would be okay. Okay, so that's how you draw the R. I stop a little bit here because I want to make sure everyone on the same place. Okay. You need a ggplot2 package, ggplot2. Is that okay? Let's try. Let me know if you have any question. Okay. So if you want, you can try to plot an exponential, plot a Poisson also for fun. Okay. So then the code for you can look at the slide again. Okay. This is how I plot the PDF, right? And you can also plot the CDF, right? You can plot the Poisson, just POIS. Okay. So basically is you can repeat all this, okay? One more downward, but now along Pn, you have a lambda there. Okay. Lambda, you say 5, okay? And here I have to put n is again the same thing, but we put a big number, maybe 100, maybe 20 will be fine, 15, because it look good. And we also have a poise, and the same thing, okay? Basically the same thing, but we change, there's no more p, okay? Remember there's no p, okay? And the same thing here. This is what the Poisson looks like. Okay, so basically same thing, but there's no p here, right? I just have to change the Poisson. And n is this how big the number is. Okay, there's no n in the Poisson, but n just like the limit of we're showing. Okay. Oh, sorry, I make a mistake. It should be lambda. Sorry, it should be lambda. So this is the graph. It's like should be concentrate near the mean. Okay. So this should be the answer. Okay, how you do the how you have this p of x and f of x, how you plot it. Okay, is that any question? Just remember, we don't have p. Okay, the only parameter here is just lambda. Okay, the n here is just like controlling how many the x limit. Okay. Okay, this is how I draw the two graphs at the same point. But of course, if you don't want the y, then you can just, you don't want the z, you just run without the last line. You can run this one only. This will give you this very nice looking Poisson. Okay. Is there any question? If you just run except the last line, then you got what the graph I have. If you run the whole thing, you got the stuff. Okay. If you miss the last line, second to the, okay, you miss the 20 line 22, then you got only the curve. Okay. So the ggplot is very convenient. You can overlapping different curves. Okay. Is there any question? If no, then I'll go to the very last thing. We're going to look on the R. Okay. So basically, exactly the same formula for every single thing. Poisson look like this, right? This is the graph here. Okay. The only thing that to be careful is hypergeometric. Okay. It's not x n a n. It's look like x a n minus a and n. Okay. So it's a little bit different from the Excel. Okay. Because you have the a and you have n, right? A big n and the good item are a, right? But here is just a and n minus a, the same thing. Okay. So that had to be different, right? So if your Excel will be your input is 4, you add up these two numbers, you have the 30. Okay. So when you do it, you know, okay, but that will be different entry there. Okay, make sure that you don't miss. Okay, just to remind you this. Okay, here compare. You can remember this one. I don't have that. This equation, right? You compare it with Excel, is different. The Excel input is you put small n first and a and n. Okay, just make sure that you don't make a mistake. When you look at this, they have n, a, and a minus n. Okay, so that's different entry. Okay, so very last thing I want to highlight is normal. Probably you know already, but they will use D norm and P norm. Okay, and Q norm will be the inverse. Okay, the same thing. Okay, just a very final one before you go, because I want you to make sure it is okay. So we want to show the P norm, okay, with say 1 point, with this one, 20, 16, 20, and 4, okay. We did P norm, yeah, okay. So this is the answer we do in the class, right? This is just the norm, this 16, 24 false, true. Okay, so this is just, if you use Excel, okay, this is norm, this 16, 24 true. Okay, this is the answer. Okay, finally I show you the last function and then I'm done. Okay, sorry for overrun for one or 2 minutes. So I want this Q norm, okay, and then 0.5, 16, maybe 95%, and then maybe I put 0 and 1. Okay, I run this guy. Okay, what's this? This is exactly, let me use another color. Okay, so this is just norm S inverse 0.95. Okay, so if 0 and 1 means standardized. Okay, so I'm done. So I hope to see you on Wednesday, but in case of typhoon, then I will see you next week. Okay, enjoy the double 9 holiday. If no typhoon, you can hike, but be careful not to hike while it's a typhoon. Okay, I'll stay around to answer any question you might have. Have a good day. Sorry for overrun for 3 minutes, but I will stay if you have any question.
I finally solved the package problem. I want to download the GG plot. Which one is?
GG plot 2.
Plot 2. Okay.
Yeah, you can run. Yeah, if you have any question, you can just ask. I'm still around to answer any question you might have. Yeah. Bye bye. Enjoy the day. Oh yes. 即係你個 app 嘅 area 你揾翻個 x， 即係 just reverse。
好，拜拜。